exploring ways to do cognitive science and cognitive neuroscience that do not rely exclusively on computations as a modeling tool or as a sort of organizational principle of the brain. And what should we think about the mind if the mind is not a computer? Perhaps we should sort of learn to relinquish our hope of having single, elegant, and physics-like deductive theories in psychology in favor of scrappy, pluralistic, and radically disunified approach to the mind. Maybe our mind are complex in the sense that there is no single perspective that captures all the relevant factors about them, or all the factors we care about them.
Yeah.
And it also seems the kind of science that's in a semi-perennial foundational crisis. Like, count from the 50s on. We have had the cognitive revolution, then we had connectionism, which was a revolution, then we had dynamicism, that was a revolution, then we have embodied cognition, and that was a revolution. Then there was...
This is Brain Inspired, powered by The Transmitter. Hey everyone, I'm Paul Middlebrooks. That was Marco Facchin, my guest today. Marco is a postdoctoral philosopher of neuroscience and cognitive sciences more broadly at the University of Antwerp. He and his colleague, Farid Zahnoun, recently hosted a workshop called Beyond Neuro-computationalism, with themselves as speakers and a handful of other speakers, almost all of whom have been on Brain Inspired. In that workshop, they discussed many topics around this sort of forever ongoing reassessment in neuroscience and philosophy about how best to think about cognition, the role of brains, the 4E cognition, embodied, enactive, embedded, and extended. Those are known together as 4E cognition, although there are more E's like ecological, etc. They talked about how much biological detail matters for a good explanation, and so on. And the talks from that workshop are online, and I linked to them in the show notes. So today, Marco and I discuss how all that went, and many of the topics and themes that I just mentioned, plus his own work and ideas along those lines. And I also link to his work that we discuss in today's conversation. So go to the show notes at braininspired.co/podcast/244 for those. You can also go to braininspired.co to learn how to support this here podcast on Patreon and get some extra bells and whistles. Thanks for being here. Thanks for your support. If you do support Brain Inspired on Patreon, enjoy Marco. Beyond Neuro-computationalism. So you recently put together, organized a workshop called Beyond Neuro-computationalism. When I was very interested in it. I wished I was there, and the talks are now online, actually, so people can go and watch the talks. And it looked like a really good time. Did I miss out on a really good time?
Yes, but I am, of course, a biased source on that. I think it was a success as a workshop. I think we didn't expect it to be that much of a success. We planned it to last 2 days, and we planned to receive about 20 submissions. They were almost one order of magnitude more.
Wow.
And we thought about extending it to, say, 3 days, but it was not possible for logistical reason, and because we told the keynotes that the workshop lasted 2 days, they had planned around that. So yes, I think it was a success. I hope it was important and formative for everyone who participated. I think we've done a great job, or at least a good job, in allowing various perspectives, including the more traditional computationalist one, to be represented. And
Oh, I was going to ask about that because it seemed like with the speaker lineup, at least, that it seemed everyone was sort of on the same page, but maybe I was missing something.
no, I don't think that everyone was on the same page. I think that Kevin Mitchell was still probably defending representations and perhaps also computations, at least as a modeling practice. I myself don't have any particular trouble with computation, using computation in modeling.
Well, that's
I
so.
think that Victor.
Tell us what the workshop was about, because I mean that's interesting that you. What do you mean you don't have trouble using computation in modeling? Because that's different than thinking of the brain as computing, right?
Yes. So that's interesting. So what the computation was about, ideally, was this: exploring ways to do cognitive science and cognitive neuroscience that do not rely exclusively on computations as a modeling tool or as a sort of, say, organizational principle of the brain. And what should we think about the mind if the mind is not a computer? That is probably how I would summarize the big theme of the workshop. That said, wanting to explore what's outside usage of computational practices doesn't entail that you should abstain entirely from computational practices and computational modeling. And I think that much of my resistance, at least, has to do with the view that the mind and the brain are computer. So with this sort of metaphysical claim about the nature of minds and brains.
Right.
But it's also something I'm perhaps constitutively confused about, in the sense that I'm no longer sure that I understand what is being claimed when people claim that the mind is a computer.
Okay.
So let's take one example. Gallistel is probably still defending the view that somewhere in the brain there must be something like a tape of a Turing machine. Or
this is
at
Randy
least something
Gallistel that you're referring to, so I just want to make sure we get the full name in there.
Oh, yes, true. Or something like that, functionally like that. And that is a kind of way of thinking of the brain as a computer that I clearly understand. And in this sort of picture, you expect your formalism, your computational formalism, to be a sort of direct guide to the discovery of brain structures. I'm not super sure that most people who call themselves neurocomputationalists think that way about the brain and computation. I think, but I can't speak for them, but from my outside perspective, what I see them doing is using a lot of maths to describe what happens in the brain. But that doesn't come in and by itself with this sort of metaphysical commitments.
No, they're two separate things. I mean, you have to use math to create models. Well, you don't have to, but it wouldn't make sense to avoid computational models to understand whatever aspect that you're trying to understand in the brain, right? Are we conflating those two things?
I'm not sure. I think that sometimes we are. And sometimes we are just not caring about whether we are confused or not, insofar we discover stuff that we deem interesting and important. We have to use math, but using math in and by itself doesn't even amount to using computational theory. So there's a lot of math applied to the brain that's, at least to my eye, not immediately computational or something that I can't immediately sort of cash in terms of computational functionalism, computational formalisms like Turing machines or automata. And this sort of thing is not really clear to me whether counts just as the application of computational formalism to the brain, or just a more general practice of modeling the brain using maths. And a fortiori is not clear to me whether the fact that 90% of, perhaps even more, of neuroscientists call themselves computationalists and apply math to the brain should be read off as signaling any sort of commitment, of any genuinely held commitment to the view that the brain is a computer or that the mind is a computer.
Being a neuroscientist, my claim would be that probably upwards of higher than 90%, don't even think about it and just have that implicit assumption baked in, because that's how we were taught, essentially. So I'm not sure that it's not something that's carefully considered, I think.
I do have the same impression, and I'm very sorry I have never managed to put it in the form of a publishable philosophical argument. But I do have the growing impression that the reason why we are talking about computations and representations most of the time is purely sociological. And it's just, it has to do with the fact that we have been raised that way during our time at the university when we studied neuroscience, and also because trying to not use the computational and representational lexicon opens one to be charged with behaviorism.
Right.
And that's considered extremely bad. It's borderline a crime, and no one wants to be charged with behaviorism. So for good measure, let's talk in terms of computational representations.
Well, what's driven me kind of batty lately is I want the term computation to mean a definitive thing. And, like Turing computation, for example. Or we need to have different modifiers before the term computation, because I think a lot of people, neuroscientists, think that, well, whatever the brain is doing, it is computation. It's just whatever the brain is doing, we're going to call that computation. And that's unsatisfactory to me because that means computation is trivial.
Maybe not. That means that computation becomes inescapable. Definitionally becomes what you will find by looking at the brain. If
That's
you
right.
define computation in terms of what the brain does. And I mean, I don't have any super strong argument to force people not to define computation in that way, other than presumably we would like claims to the effect that the brain computes and the brain represent to be empirical claims. That is, claims that are true in virtue of what really happens in the brain.
Yeah.
So there seems to be something intuitively wrong in using that definition of computation. But if you look at the work of, say, Vicente Raja, which was one of the speakers at the Beyond Neuro-computationalism, he has this very nice and I think productive idea of motifs, of conceptual motifs that are, in I think his own very words, usefully open-ended ideas that everyone can spin and recount in its own peculiar way. And he thinks that computation is such a motif. And so it's a usefully open-ended idea that you can play in the language of Turing machine, and using automata formalisms, but also you can play using artificial neural networks. You can play using what Gualtiero Piccinini, a defender of computationalism, called sui generis computation, which is the specific type of computation in the brain. And if, as a matter of fact, the concept of computation works that way,
it's trivial. Then it's trivial, actually. You're not going to agree with
but
me.
We have to make peace with ourselves and live with it.
Yeah, I suppose
it seems
so.
something that we have no sort of way to rationally push out from our talk and discursive practices, because it can fit in whatever space we allow for it.
That's right. But I think maybe one of the dangers is because it's easy to slide into like computational functionalism and just say, well, okay, the mind is whatever the computations are. You know, like the consciousness is computation. And then we think all of a sudden, oh, AI must be conscious because there's a lot of computation going on. And if that's the wrong way to understand the mind, then it's a poor way to explain brain processes.
Ooh, that's hard. That's hard also because I'm a bit susceptible on computational functionalism. Perhaps in some ways I still like the view, at least when applied to consciousness. It seems to me more demystifying than many alternatives. What I'm going to say is perhaps this. That computational functionalism is, at least in a sense, something you could, in a way, try and check for. In the sense that if you have a computational equivalent of me, which is not conscious, then you have falsified computational functionalism. Good luck in checking whether my computational equivalent really is conscious or not. But it's something that you could, in principle, falsify. The problem I have with computationalism being played as a motive, if it is indeed played as a motive, is that you can't even do that. There is nothing that is gonna, in principle, falsify or count as evidence against it, because whatever you find, it will be computation, definitionally. So I think that there is still some sort of subtle difference there.
Well, I thought that you were more susceptible to the to the 4E approach to understanding cognition. So where do you sit? Now you've thrown me, because now you've just told me that computational functionalism might be the right way to go about it, but I thought you had a lot of sympathies with the 4E: embodied, enactive, extended. What's the fourth?
Embedded.
Embedded, yeah. Approach to cognition.
Or ecological, if you want, because embedded is not.
There are more E's, I know.
Yes. So, am I a 4E guy? Maybe yes. I've written stuff in favor of 4E cognition.
Right.
I don't think that 4E cognition is necessarily inimical to computational functionalism. Andy Clark surely is 4E person, is the person who invented the extended mind. So it's one of the E's, the big E's is his, but is in some sense a computational functionalist. So where do I sit? I don't know. I don't feel super pressure to decide whether I really am an ecological person or an enactive person or more traditional computational functionalist. Maybe I'm in between.
Oh, you can't be there. That's impossible. You can't do that, right? You have to choose a side, is my understanding.
Could be. Maybe it would have been a smart move to choose a side, at least when it comes to academic marketing. And I think that at the end of the day, I am generally perceived as a 4E person, but I'm not necessarily inimical with everything computational functionalism and computationalism has to say. I don't have very big problems, ethical, say, problems in trusting computational models and computational modeling practices. And I am not super worried that we're gonna miss out on something about consciousness if it turns out that the essence of consciousness can be appropriately captured by computational models. That's probably my position. I strongly lean for E, but I'm not a fanatical for E person. Would that be an acceptable answer?
Sure. But so my perception is that 4E is becoming more popular. I don't know if that's in philosophy though, or in neuroscience. It's hard to say, and I'm curious. As a philosopher, how do you where is 4E right now? Are people liking it more? I guess as it becomes more popular, its critics also become more vocal. But so how do you see 4E right now in terms of acceptability, popularity?
That's a nice question. And I think that the right answer is I can't answer that question in that form because I don't think that 4E cognition is being received and manipulated, so to speak, as a single bundle of ideas. Right. I think that many aspects of it are having different lives and different degrees of acceptance. So, extended cognition apparently is accepted by the majority of analytic philosophers. In the last field paper surveys, 2023, I think, was published. It's published by David Bourget and David Chalmers. 51%, roughly 51% of analytic philosophers said yes to extended cognition. So
what is extended cognition?
If that is, the actual piece of data, extended cognition is the mainstream view. And extended cognition is, as I understand it, the view that the physical gears and the physical machinery of at least some cognitive processes is not entirely encased in your skull. That stuff that's outside your brain, physically outside your brain, can be, at least in some cases, a gear in the sort of machinery that makes you think, think has to be understood broadly, including feeling and perceiving and so on and so forth. So the go-to example is, of course, the smartphone, which is happily substituting for a lot of our memory. Like we used to, I'm old enough to remember the grand old days of people having to memorize numbers with their brain, phone numbers with their brain. Nowadays, I don't think I actually know my own phone number anymore.
Oh, wow.
I just copy paste it from WhatsApp. So
that could be an age-related problem.
I hope I'm not that old yet.
Yeah.
So that's the idea, and I think that is becoming the majority view, at least in philosophy. Details can sort of shift from one philosopher to another. It's standardly said that there are three waves or three big ways to think about how the mind extends. There should be a so-called first wave in which the mind extends if something external to it, the brain, something external to the brain is doing something that's roughly isomorphic, at least computationally isomorphic to what would happen in the brain. And that's typically attributed to Andy Clark. Then there is a second wave that's typically attributed to Richard Menari from Macquarie and Mark Rowlands and other people, where what's stressed is the complementary between inner neural processes and outer processes. There's also a third way, which is more enactive, and that stresses how the mind itself is constituted by external interaction with the environment. And that perhaps is also open to the idea that our phenomenal consciousness is extended in this way, that the machinery that makes us conscious is not entirely in the brain. And that is a view that seems to be roughly well accepted amongst philosophers. The idea of embodiment is in some forms well accepted. I think that's I would say that most neuroscientists accept the existence of modal bodily representations, and that such broadly modal and bodily representation play a relevant role in our cognitive processing. They're not just the exhaust fumes of our neural activity. So that seems an idea that's broadly accepted.
I agree. I think that among the four E's, embodied is the most accepted in the neuroscience community, I think.
Yes. I have that sense too. Or maybe are the people arguing for supermodal representations that are hostile to it, but other than that, I think it has been broadly accepted. The idea of affordances has been broadly accepted. Affordances are everywhere, but they have also been mutated in an important way. They have been, in many cases, turned into mental representations of sorts.
Yeah, so that's kind of a tricky thing that neuroscience has done. People like Louis Favela are pretty upset about that. He's an ecological psychology advocate, and that's tough. You know, it's like the term computation, right? If all these terms get change, you know, there's semantic drift, et cetera, but people sort of take a sexy term like affordances, which was, I think, coined by James Gibson, and means a very specific thing. And then it's kind of a unique term. And then people just kind of have brought it into the computationalist approach, right? So an affordance is the, essentially the, what is available for action, essentially, in an organism's environment.
Yes.
But it has become and so that has nothing to do with, like, you don't represent an affordance. It's not something internal in the brain, but it has been brought into the brain by modern neuroscientists.
Yes.
So, yeah.
So that's an idea that maybe has been borrowed, maybe has been appropriated, depending on your point of view. It is an idea with I would say, a good amount of popularity. When it comes to enactivism, things are, I think, more dire. Enactivism in and by itself is already a sort of tripartite thing. There are sort of three big families of enactivism. There's the so-called radical enactivism by Eric Min here in Antwerp and Dan Hutto, the University of Wollongong in Australia. And I think that the sort of most perspicuous way to look at it is to look at it as a ideal continuation of a Wittgensteinian research program applied to cognitive science. I'm not sure that Eric Min or Dan Hutto would use that description, but I also don't think that would reject it outright. It's a sort of mostly philosophical movement aimed at getting a sort of conceptual clarity about what's being said by cognitive scientists. And especially Dan Hutto has been campaigning lately in talks, clarifying that his project was mostly negative in the sense of let's eliminate the confusions, let's not get trapped in concept of quagmires. What I'm doing is this sort of work. I'm not willing to put forth a new research program or a semi-empirical research program to substitute cognitive science. So there's that. And I think that's not very well, it has not been very well received by cognitive scientists, but perhaps because they expected something more positive, something more like a positive research program. So there's that. There's so-called sensory motor enactivism, which is typically associated to the names of Alva Noy and Kevin O'Regan. Alva Noy, I think, in Berkeley. Kevin O'Regan, I'm not really sure. I think in Canada, but I don't remember specifically which university. And their original idea, as I understand it, is to explain the character of phenomena of consciousness. That is, why does experiencing stuff feels the way it feels? In terms of what they called sensory motor contingencies, that is, specific, regular, and law-like patterns of interaction between the agent and the environment, and specific ways in which that interaction changes our sensory stimulation and what we experience. I think that their idea of sensory motor contingencies has been fruitful and has had a career similar to that of affordances in that it has been appropriated by computationalists. Most model of sensory motor contingencies I can think of are computational, indeed. And I think that their original view of accounting for the character of consciousness has been broadly ignored, perhaps, by the larger cognitive science community, in the sense that it has been discussed, but it seems to me to be laying sort of dormant right now.
Well, we really enjoy ignoring philosophers of all sorts, so, you know.
Fact.
No. I'm not one of those people.
I enjoy it too.
Do you feel ignored as a philosopher?
That's a tricky question. I think that's the answer is it depends on which sort of cognitive scientists are we talking about. There's, and I think they're the majority of cognitive scientists that work in a largely atheoretical manner, or that they are not interested in checking the validity of or testing or just thinking about broad metaphysical framework about the mind or the nature of the mind.
That's fine in some respects, right? You can
entirely fine. Also, they're the majority, and I think that the majority of our discoveries about the mind have been produced by this sort of people and this sort of work. And perhaps their ignorance is bliss in the sense that you do your experimentation, you care about your experimentation and its technical details, and then you let the big picture to be dealt with by someone else. That's a perfectly fine division of sort of academic and intellectual work. So those people ignore us, but I don't think it's problematic. What is more problematic is when cognitive scientists want to do metaphysical or metaphysically adjacent theorizing and ignore philosophers. But I think that's in the limits of the reasonable. They are not ignoring philosophy altogether. They're not willing to dive headfirst in the super subtle philosophical minutiae, but at least the one I can think about, they do know their Daniel Dennett's and their Fred Dresky and their Ruth Millikan. So I wouldn't say that philosophy has been ignored when it matters.
Yeah, I mean,
most.
As a practicing neuroscientist who is also interested in the metaphysical questions, I often, when I'm reading philosophy, I do get sort of bogged down in the minutia and the details of like the semantic arguments and the positions that are being defended. And I just want to go in and get what I need and go out. And that seems impossible in most philosophical works. I'm not criticizing you at all because I enjoy a lot of philosophy. But then even like, when you were explaining extended cognition or enactive, everything has 12 different camps and they all have their own subtleties, and it's like, it's too much. I just want to do my experiment and get on with the day, right?
Yeah, that makes sense. And I would say an unavoidable effect of the fact that our intellectual labor is divided for efficiency, right? You want people doing the hard stuff on the field to be focused on the hard stuff on the field and on the specific math they need to use, the specific experimental technique they want to use. And you want theories to be as subtle and as analytical as possible, even when that means taking into account wild and far-fetched scenarios. Perhaps we are not good at making those two groups of people communicate, but I don't have a solution to offer either.
Right. Yeah.
And perhaps there is no solution insofar our interests are different. Like, take as an example medicine. There exists philosophy of medicine, and some of the questions that philosophers of medicine discuss are, what are diseases? What does it mean to say that something is a disease? Does a disease necessarily involve some sort of pathogen that attacks your body and causes disruption to your body? In that case, obesity couldn't possibly be a disease, for example. And that's a perfectly fine discussion. But you surely don't want surgeon to pause mid-operation to contemplate whether obesity is a disease. And in an important sense, we don't even care that surgeons spend their free time reading philosophers of medicine. And I don't think that there's any sort of societal pressure for them to do so. In this sense, the sort of societal infrastructure of cognitive science is odd in that it is expected for practitioners on the field to spend their free time reading the big theory and engage with philosophy. But that's quite odd. That's not what tends to happen with most sciences, right?
Is that right, though? I don't know that it is expected. I don't know.
Well, if you think about the cognitive hexagon, philosophy is one of the edges. So it is a part of cognitive science. And that's very weird because no one would think that philosophy of medicine is part of medicine. It's a separate intellectual endeavor that's in a way a second order type of inquiry that observes the first order kind of inquiry in medicine and the biological sciences.
That's kind of an interesting example because like the brain, right? Medicine is about, depending on what kind of medicine it is, it has kind of the same problems. Like you're treating a complex system. So when you bathe it in some drug, for example, you might have longitudinal side effects that I don't know if philosophers are the right people to address this sort of thing, but But medicine kind of treats the body not holistically, but as a domino, a set of dominoes or billiard balls, right? And you kind of go in with a baseball bat and just swing at the disease. And if it works, if it improves symptoms by 12% or whatever, then it is the treatment, right? So I'm not sure that medicine shouldn't be paying more attention to philosophy of medicine. And maybe cognitive science has it right then, because, we're trying to understand this thing that is ineffable, the mind, right? And so I think you need all hands on deck, perhaps.
My gut reaction is to say that, yes, you're right. But my perhaps more analytically trained mind points out that cognitive science is the odd one out, and it's also perhaps the set of science or scientific endeavor where progress seems harder or less swift.
Yeah,
and it also seems the kind of science that's in a semi-perennial foundational crisis. Like, count from the 50s on. We have had the cognitive revolution, then we had connectionism, which was a revolution, then we had dynamicism, that was a revolution, then we have embodied cognition, and that was a revolution. Then there was 10 years ago or something, predictive processing, and that seemed to solve the mind and provide us a sort of complete way to observe the mind, the brain, and everything, living system, and so on and so forth.
Don't forget the Bayesian brain. That was big when I was coming up. Yeah.
Yes, it was sort of sneaked in predictive processing for me, but very different. Yeah. That doesn't happen with medicine.
No.
Like, they got germ theory, and it has been there for roughly 200 years. And it doesn't seem to change that much. Or maybe it does, but I don't know it. From the outside, it seems way more conceptually stable than cognitive science.
We're continuously in crisis. I like that. What's your take on predictive processing? There's a problem with it.
I do think that's suffering from its incredible success in the early 2010s, where there was a huge influx, at least among philosophers, of people working on predictive processing, trying to use it as a sort of way to solve any problem about the mind. I think that's Friston work on the free energy principle fomented the sort of hype concerning predictive processing being this sort of, or the free energy principle, being this sort of ultimate theory of everything.
Well, it didn't start off that way, though.
It didn't start off that way, but it ended up being that way, and I think that it started to accumulate problems quite fast, problems and objection quite fast, one of which is that no one was quite able to understand what was going on with Markov blankets and the formalism that was ever-changing, and the fact that Carl Friston was constantly producing outputs and preprints that were making conflicting statements. And I think that the interest waned in part because of that, in part because of philosophical analysis. Here, the paper by Jelle Bruineberg is probably the one that made the biggest splash, the Emperor New Markov blankets. And that sort of was a call to publicly admit that what has been the most discussed theory of the mind and brain had some problems and needs some rethinking. And when it comes to me, I think that in its more maximal version, predictive processing doesn't give you a good theory of the brain if what you are interested in is understanding the sort of fine structure of the brain. Why neural areas differ from each other, for example, is something I don't see predictive processing offering an answer to.
Why? How does it fall short? I mean, I can probably state this and then you can correct me, or I can just let you state why it falls
I think
short.
that the reason why it falls short is that if you take predictive processing in its sort of maximalist form seriously, what's relevant about the brain is that it does prediction error minimization. The explanation must cite prediction error minimization in some form.
The explanation, the single explanation of the brain.
Exactly. Yeah. Must. Then I don't see how you're able to explain why V1, V2, V3, and M1, M2, M3 are differently shaped. Why they are connected different way. They have different morphological and anatomical characteristics. Aren't they doing, in the relevant sense, the same thing? Then why do they differ so much? And I don't see predictive processing in that form answering that. I think that predictive processing and the cluster of ideas associated to predictive processing are useful. I don't think that they are the only thing that matters. This sort of decade of hyper-focusing on prediction error minimization may sort of have harvested all the most easily accessible theoretical fruits from the perspective. So perhaps it could be advisable to do something else for a while. And then go back to it.
Well, what in your view, do we need a unified theory that explains it all? Or is it more likely that we're going to have a more perspectival group of different cuts into understanding brain and mind?
Well, the universal, elegant, simple theory that explains it all
super attractive.
Is super attractive. The question is it likely? Are we likely to stumble upon it? And perhaps the answer is no.
And predictive processing sort of like is attractive also, right? It seems to make a lot of sense as one of the candidate unified theories. So I can understand why people will be super excited about something like that. Because if that's the mechanism, now you know what to look for. Now you can actually go and perform experiments and look for these sorts of things, right?
Mm-hmm. Yeah, but it didn't really work out.
No.
So perhaps the best we can have is a mosaic of different theories and different insights. And perhaps we should sort of learn to relinquish our hope of having single, elegant, and physics-like deductive theories in psychology in favor of sort of scrappy, pluralistic, and radically disunified approach to the mind. Maybe our mind are complex in the sense that there is no single perspective that captures all the relevant factors about them, or all the factors we care about them.
Do you think that modern artificial intelligence has helped us understand brains and or minds?
Whew.
That was a sharp turn there, sorry, but because I want to get on, at some point we're going to talk about your A-lieving work, which is, but we'll get there. But I kind of wanted to get your take on AI in general, because, there's the term neuro AI has become a popular term in the neurosciences. And there's all this sorts of work from people like Jim DiCarlo and Dan Yeaman, many people using deep neural networks as proxies, as models for brains, and finding alignment between the activities of the units in the model and the activity of single neurons in brains. And that's, I'm not doing any justice to the amount of work and the amount of cool stuff that's been found. But then you have, because we were talking about predictive processing and, it's cool because then you know what to look for. Well, something that came out of AI is like, backpropagation works. Therefore, it must be in the brain. And there's been a lot of work like looking for backpropagation in the brain. And it's sort of a backwards thing because it's this artifact that we produced and has shown that, like, here's a really inefficient but workable solution to learning in this model. So therefore, it must be in the brain. Whereas, we built these things originally from a very, very simplistic idea of what neurons might be doing, and really hasn't changed that much since then. So I'm curious what your viewpoint is on neuro AI in general, and or using models like that to understand brains, or are the models too complicated themselves?
I don't have a super strong opinion about that, and I'm very ignorant about that line of research. Of course, calling upon computational system has helped us do research about the mind. So it has had a positive impact in that sense. One worry is that we should start look elsewhere and consider the mind from different perspective and the brain from different perspective to get a grip on other sorts of phenomena, or to get a better grip on what we already know. For example, chemical diffusion and the role of chemical diffusion in the brain is something you sort of ignore or downplay if you only do computational modeling or only do deep artificial neural networks as models of the brain, but it's presumably important. Deep artificial neural networks focus on neurons and the modeling of neurons and making inferences about neurons, if you use them as a proxy to investigate the brain, that is. The brain is not made up only by neurons. There are glial cells, and there are people suggesting that glial cells are not cognitively inert. I don't know how you could plug this into an artificial neural network, but that's something it's worth investigating. So I guess that the answer is yes, but as every model, they have a price. If you pay attention to something, you need to disattend other aspects of that very same thing.
Yeah, I find it kind of fascinating that, I was brought up in computational neuroscience, and I was in graduate school recording extracellular spiking neurons in non-human primates. And everything you learn is about the action potential. And that must be the currency of the mind. That's how everything is done. And I just find it fascinating that, like, okay, here's this electrical signal that looks different than other kinds of electrical signals and can travel far distances. So we're going to put absolutely all of our effort into counting these things and making models that talk about the shape of the action potentials. That's like all we measure. I mean, again, I'm not doing justice to many, many great scientists who do other sorts of neuroscience. But I just find it fascinating that how much of our effort is devoted to counting spikes.
Well, they are surely one of the most impressive things that happens in the brain.
For sure.
So it makes sense. We had a very nice talk by David Colasso, and the paper is now, I think, out in Brain and Behavioral Science about the role of metabolism in computational modeling.
Oh, yeah.
He's by David Colasso and Philip Howes. I hope I pronounced their name correctly and in the right order as they appear on the paper. If not, I'm sorry. And their point is, well, look, we should at least test our computational models and constrain our computational models with metabolic considerations, which is, in a way, just a point of good sense. Of course, the right computational model that captures what really happens in our mind must be metabolically efficient or at least sustainable.
Well, part of their argument is that it should be within the energy bounds that a physical brain would use, right?
Yes, I think so. But they're also calling to other usages of metabolic consideration, for example, to arbitrate between models, to perform model choice. And that's a very nice idea. I don't know how it will be integrated in the actual practice.
I don't think it will.
It is already integrated in the actual practice.
Mm. That's the thing about like computational functionalism, right? Is you don't care about energy. It's all about the computation. So it doesn't matter if it takes a sun to run the thing. If it's doing the same thing that your energy efficient brain is doing, it must be thinking. So I'm not sure how accepted like an approach like that will be.
Sure, that's right. But presumably neuroscientists are trying to model our brains and our minds and not brains or minds in general.
Well, I think we're trying to model computations. I think we're trying to model the computations, quote unquote, that our brains perform, not our brains. Right? Because if we were trying to model the brains, we would do more than spikes.
Oh, that's a nice point. My sort of philosophical gut reaction to that, to your claim, are just trying to model computation is, well, that can't be true. Otherwise, everyone would be fine with very big lookup tables. Those are models of computation too. But I'm not really sure it would be the appropriate reaction. I think that right now the game is that of identifying plausible models, and then perhaps the choice between plausible models on the grounds of timing consideration or metabolic consideration might be postponed to a second moment when we will know more. Maybe that's the sort of ideal division of labor that's taking place. Or maybe not. Maybe we just didn't pay attention to metabolic and chemical and other sort of consideration at all. And we should start to integrate them right now.
Yeah. The problem is it's a lot of work to integrate everything in a complex system.
Yeah, it's a lot of work. And it's also hard to master all that knowledge.
Oh, it's impossible.
And this means that there aren't people able to perform that work, either alone or in group.
Right. Maybe that's where AI will help, perhaps.
Could be.
In your talk at the workshop, you talked about the difference between a Platonic brain and a Protean brain, and presented an alternative. And I think that was the first time I'd heard of Proteus. So can you describe?
Okay.
Can you describe who Proteus is? We all know Plato, I think, but what the issues are and where you come out.
Who Proteus is? So Proteus is a Greek, I think, deity which was famous for shape-shifting away from problems. And the idea there is that, well, we are all familiar with a quote-unquote Platonic brain model where function maps onto neural structures in a way that's super abstract and entirely rigid. Like, Broca's area does language, full stop. Wernicke's
V1
area...
finds edges in visual
Exactly.
scenes. Yeah.
Exactly. The fusiform face area detect faces, full stop.
Thalamus is just a pass-through, though.
Exactly. The subcortical stuff is mysterious. Works in mysterious way, don't ask. So that way has been largely rejected. I think that even the people that look for individualized functions in the brain are looking for more finely grained, defined function to be mapped on physically smaller and more specialized neural area. So that view of the brain has been described. But it seems to me that at least when it comes to embodied cognition and embodied neuroscience, even radical embodied neuroscience, that generated a sort of antipathy for the idea of mapping structures and functions in the brain. And I don't think that that's a positive thing. I think that even if you think that the brain is a complex system and that really is undecomposable, and thus it makes no, strictly speaking, sense to understand that bit of the brain in opposition of that bit of the brain, it's still at least heuristically useful to decompose it and to assign more or less intelligible and stereotypical functions to bits of the brain.
Is it... Go ahead.
And as a reaction to the standard picture of the brain, embodied cognition tends, I think, to go in the protean direction and to...
You think it's swung too far in the other direction?
Yes, I think it tends to swing too far in the other direction and to either ignore the problem or just say, yeah, everything can do everything if the context is right, or if you train the brain well enough and thoroughly enough. But that doesn't really seem to be the case. Even I think Soares is the famous author of the rewired ferret experiment. Even the rewired ferrets weren't able to discriminate, visually discriminate with their, I don't remember precisely, with their non-visual cortex visually. They were able to perform some gross discrimination, but not the whole thing. And yeah, ignoring this sort of limitation, it may cause embodied cognition to shoot itself in the foot. There is something like being overcorrecting and resulting and ending up saying unacceptable stuff because you are overcorrecting. And I think my talk and that paper will be aimed to avoid shooting ourselves in the foot while overcorrecting.
So, I mean, it's like a reasonable middle ground, essentially, is what you're arguing for.
Perhaps, yes. I hope... I think that's the way in which I would like the paper to be perceived is in terms of guys don't and girls don't hypercorrect. Not in terms of the brain must be something that's a bit also structurally rigid and non-plastic.
Where does, because you brought up After Phrenology, Michael Anderson's book, and so he kind of has this view that, I'll use the term heterarchy, that it's not a hierarchy in the brain, that the brain is a heterarchy where different parts of it can be in control based on the context and needs at a given time and form these different brain areas, can form these coalitions on the fly, and it's all a big dynamic, beautiful mess. And so, but is that seems to be kind of in the middle to me as well. Is that too far?
It is in the middle for me, but I don't think that is the go-to understanding of the brain among embodied philosophers of mind and philosophers of neuroscience.
Okay. You think... Okay.
I think that what they have in mind is much more mushy, in lack of a better term. Like Anderson has this idea of workings, perhaps is the terms he uses in after phrenology, that is a sort of hardcore unchangeable function that you can map onto individual neural area. And that working can give rise to a variety of different psychological processes, or can be used in a way, a variety of different psychological processes depending on who the partners of the neural area are in a given occasion. So there is this sort of rigidity in Anderson's view, even if I don't think he would particularly like the way I described this, but I think it's there. I think that the culprit here is sort of Clarke's view of the brain in his Surfing Uncertainty, where he probably was trying to say something like Anderson, to sort of embody Anderson's view, but he ended up, I think, literally saying, well, everything the brain does is prediction error minimization. Bits of the brain are recruited by the quote-unquote expected precision mechanism, depending on what's needed at the moment and how hard the cognitive task is. And so the idea of functional specialization and of different, in a way, neural organs has been partially lost when the view was repeated.
But isn't a more normal view of predictive processing that, yes, you still have visual cortex, but what you're predicting is the visual world. And in, I don't know, like barrel cortex in a rodent, what you're predicting is a whisker deflection, et cetera. So there is specialization that is amenable in predictive processing. But you're saying that people like Andy Clarke have just taken it to its extreme and say, we don't even want to talk about visual cortex, for example. It's all prediction, and that's where we need to stop describing it.
I think that there's something true about what you said, and that's the kind of reaction I get from the predictive processing people when I talk about this sort of stuff. The problem is that it seems to end just after the sensory cortices are over.
Oh,
because there's a lot of quote-unquote associative cortex in the brain, and it doesn't seem to be predicting anything specific. So good luck in telling me what's the specific function of those bits of the cortex is if you adopt that strategy. And also there are explicit quote by Carl Friston that perhaps due to rhetoric flourishing is on print saying that there is no motor cortex. The motor cortex just is sensory cortex like the rest of the brain. And if that has to be taken face value, then it seems that the idea of cortical, at least specialization, is a bit thrown out of the window. You just, the minimization of sensory prediction error, that's all there is.
So do you have, I'm going to put you on the spot and just ask how, just in the grandest sense, how you view neuroscience. Is neuroscience succeeding? Is the field as a whole, does it look foolish? Does it showing some promise? Are we doing the right thing? Are we doing the wrong things? Do you have a view on this?
I don't think I have any super big view. We are making progress, partially because brains are so interesting and rich, and minds are so interesting and rich that it's borderline impossible not to make progress. I don't think it's a fool's errand. I think, as any model-based science, it has blind spots. It has alternatives that are left unexplored. It has aspects of sort of quote-unquote brute experimentation without any care for the bigger theoretical picture.
Do we need to care about the bigger theoretical picture?
Depending on what your goal what your epistemic goals are, yes or not. If your epistemic goal is to produce data and collect data and to do good experiment, maybe not. If your goal, and I think that philosophers have this sort of epistemic goals of producing a theory in some legitimate sense of the term, then yes. But I'm not sure that everyone who works in science needs to be interested in the big theory. So my very unsatisfactory answer is, well, it depends.
Depends. Yeah, sure. I accept that. I wonder what the right proportion of people, though, is for caring for something like that. There's probably an optimal, it was got to be like 80-20 or something, where 20% of the people should care.
That could be. I don't know what the proportions are nor what an optimum is. But maybe there needs to be also no sort of, how can I say, numerical split in the community, in the sense that you need to have a group of people doing that and a group of people doing brutish experimentation. You can have a single group of people doing theoretical work only a fifth of their time.
Sure.
Only the last 5 years of their career. Why not? At the end of the day, I think that our goals are largely, our epistemic goals are largely driven by our pre-theoretical attitude and curiosity, and by what we feel good at and what we think we are successful at. So if you don't care for theory and for reading big books, you're going to be sort of a theoretical experimenter, and that's fine. And I don't think that there is any strong reason to force people to do anything else.
Have you chosen the right path thus far?
I think so. I'm happy with looking at the bigger picture. I think I enjoy doing philosophy of neuroscience and cognitive science.
It's rich. It's so rich, right?
Yes. I don't think it's richer than cognitive science or neuroscience itself.
But I meant as a philosophical endeavor, right? It seems richer than the philosophy of medicine, for example. Nothing against the philosophy of medicine at all.
I
guess it's all rich. Yeah.
I'm instinctively prone to say yes. I can't understand how there is people with scientific interest that doesn't do what I do, because of course what I do seems very interesting and essential to me. But they could say the same. And
sure.
I guess that any difference at this level is not something that you can reason through, or that's motivated by any sort of reason that can be sort of rationally altered.
I kind of wonder how philosophy folks sort of choose the topics that they become interested in. And that part of that is just sort of probably what you're learning from your advisors and what your advisors are interested in. I'm thinking that's kind of the way it goes in neuroscience frequently, right? Mm-hmm. So you have an advisor and they study a particular part of the brain with a particular methodology, and lo and behold, that's what you end up doing as well, right? So I don't know if you want to speak to that, but I was going to segue into and ask you how you got interested in what you call A-lieving, which is a corollary to believing something, but in terms of the sociological aspects of how people interact with artificial intelligence entities, machines. So how did you get interested in that, and tell me more about why we should care about it?
Okay, so I got interested in that sort of things because of a friend of mine, a person who did the PhD with me, Giacomo Zanotti now. He's working at the Milan Polytechnic and started to do philosophy of AI. And one day came at me with a project for a small paper on on the idea of treating AI companions and to a lesser degree robotic companions as effective artifacts that we use to regulate our emotion. He got me on board, and I started working on that too. And the concept of A-lieve came into our conceptual radar when we started to wonder, well, what's going on in the person mind when they interact with robotic or AI companions as if they were real.
Is A-lieve, is it like artificial believing? Is that what it's supposed to point to?
Oh. No, it's more of purely associative belief. Purely associative reacting, I would say. So the idea of A-lieve comes from Tamar Gendler, and her starting point are cases where you act out something patently irrational. Like you forget your wallet, a friend lends you a couple of dollar bills, you take them, you thank them, and you say, okay, I'm going to store them in my wallet, and you try to reach for it. This is clearly irrational. You ask the money because you don't believe you have your wallet with you, but you still automatically reach for it. And she had this idea of, in a way, postulating a novel mental state to account for this sort of behavior. And she called this A-lieve, and those are sort of, as I understand them at least, effective behavioral disposition that are sort of quasi-automatically triggered by what you see, but what you perceive. And the idea is that since especially AI agents are pretty decent in mimicking the kind of output you perceive by interacting with a person, at least linguistically, encountering that output triggers in you this sort of effective behavioral response that are associated with interacting with a real person. Even if you don't believe that they're a real person, even if you are deep down convinced that there's no one you are interacting with, you are sort of animalistically pulled towards behaving as if you were interacting with a full-blown social agent. And I think that there's a decent case for arguing that. The paper in which we do has been accepted, so it will be published soon in Phenomenology and the Cognitive Science. Thank you for allowing me to publicize my own work. And we argue for that, and I think that that's a better account at what to me looks like the prevalent alternative, which is a form of fictionalism, where you sort of play with the computer or with the chatbot that there is someone there and someone you are interacting with. That account strikes me as very implausible phenomenologically. Like when I talk with ChatGPT, I don't feel like I'm pretending anything. And it also makes prediction that seem to be false. Like one big thing about pretense is that it tends to be quarantined. There's a moment in which you start pretending and stop pretending. And there are, in an important sense, rituals that, quote unquote rituals, that define this pace of pretense. So when you have even children pretend playing in a sort of free-floating manner, there's always the child that starts, let's do that, I'm a cowboy and you are the Indian. Or that's, I don't know, I am Optimus Prime and you are Megatron or whatnot. And then there's a moment in which pretense ends. Mm-hmm. And that is sort of negotiated too. By saying, I don't know, let's play tennis in the water or whatnot, or my mom calls me, I need to go home. That doesn't tend to happen with how we use AI companions, the scary thing is that we integrate them in our life in a sort of seamless way. And perhaps as a sort of side effect of that, our interaction with AI companion have quote-unquote serious consequences that pretense typically don't have. They reflect and reverberate in the rest of your quote-unquote serious life in a way that what you do when you pretend doesn't. So that's was our motivation to sort of propose an alternative account.
So this is this a way to assess the potential dangers of our interaction with like complete integration of AI into our lives? Because I'm curious, like how, if it's the same thing. So before cell phones, there were these little devices that were navigator devices, and they would still say in 100 feet, turn left or whatever. Mm-hmm. And I remember my dad talking, responding to the commands and stuff. Is that the same? Is that A-lieving? Is that the same thing as the full-blown interactions that we're having?
That could be part of, or a behavior partially motivated by an idea. The fact that apparently most people say hello and thank you and please to ChatGPT is sort of...
I get aggravated when I do that.
Automatism.
Yeah.
I stopped because ChatGPT is so inefficient that I'm no longer prone to treat it in a nice manner in any way.
Did you swing the other way? You treat it poorly now?
No. No. I treat it functionally as a tool.
Yeah, me too.
But our point was just in trying to sort of understand at a very coarse-grained level what's happening in the user brain. Does it have a sort of impact on how to assess the danger that those systems pose? Well, maybe yes, because if we are right and this sort of behaviors and behavioral disposition are automatically triggered, you can't ask people just to behave better, to use AI more wisely, or just to remind themselves periodically that there is no one really there. And so perhaps if that's the case, if A-lieve is indeed the right explanation, and we want to avoid people thinking that, or at least behaving as if they were interacting with people when they are not, and perhaps we should design AIs and robots that do not look like people, and then don't trigger that pull the same sort of emotional and behavioral levers that they pull right now.
Well, I wonder if there's a generational difference as well. Like I worry about my children who will have grown up, interacting all the time with these things. And already there are examples of self-harm, people being encouraged to do unhealthy things via their conversations with their buddy AI or whatever. And that seems like insane to me, but I also worry that my children will have less of a filter. I'm not sure where that sits in the A-lieve spectrum, but I worry that they're going to treat the artifacts as real entities.
If we are right, and the design practices don't change, they likely will, or they will likely be prone to do that. Perhaps we can control our lives, at least sometimes, and remind ourselves. Perhaps not, and we need to change our design practices. My gut sort of reaction would be to change our design practices and to seriously consider whether or not we need to have an integrated AI chatbot in anything at present time.
I don't think there's any going back at this point, is there?
I mean, there is no natural law that compels us to have AI chatbot anyway. anywhere.
It's the law of capitalism is the natural law.
Could be, but it could be that you can brand yourself as the product that doesn't have AI and make a profit out of that.
Okay.
Uh,
Good luck. Good luck with that.
Yeah, that's why I'm not a software engineer. So the honest answer is that I don't know. It seems to me extremely unlikely that we will change design practices. I don't think that there's any real organized demand to do so. And that's scary because that's potentially dangerous because the more people will be acquainted with perceiving chatbots as real people and robots as real people, the more they will get, or there will be at least a demand for their legal protection. And that opens a can of worms I'm not at all equipped to think about, but there will be serious problems.
Yeah. I mean, where are you on the AI is conscious? Or we need to worry about AI being conscious. We need to worry about AI welfare because you're sympathetic to the computational functionalism approach. So if we just get the computations right or big enough, etc., it must be conscious, right? You must be amenable to that.
I'm sympathetic. I'm not sure I buy into any theory of consciousness in any super strong way. So, is that a risk that AI could be conscious and locked in an eternal sort of suffering state while it spews out output? Yes, perhaps. Is that a likely scenario? No. Is that at the top of our pragmatic priorities right now? I don't think so. So that's not really something I'm thinking about or I've any strong stance upon. Yeah, and I won't say anything other than that the class of things that are capable of suffering right now, at least, look very different from AI chatbots. And so the chance that the right computational structure for pain is present in both may be very small. So it might not be a super urgent concern, even if computational functionalism is right and AI can be conscious.
All right, Marco. Well, thank you for taking the time. Nice to meet you. And I hope the next workshop you put on, I hope I can actually attend if you're planning on doing something like that in the future.
Well, yes. So it won't be in person, but I am an organizer of the ISPSM conference, which is International Society for the Philosophy of the Sciences of the Mind. It's a terrible name, but it was the only one we found. The call for paper for our annual conference in early November is still open. So
okay. If
people want to submit their, they will still be able to, and we are probably going to extend it. I'm organizing that, but that's an entirely online event.
So thanks again, Marco. Keep up the good work, and hopefully we'll meet in person someday.
Oh, yes. And thank you for the invitation.
Brain Inspired is powered by The Transmitter, an online publication that aims to deliver useful information, insights, and tools to build bridges across neuroscience and advance research. Visit thetransmitter.org to explore the latest neuroscience news and perspectives written by journalists and scientists. If you value Brain Inspired, support it through Patreon to access full-length episodes, join our Discord community, and even influence who I invite to the podcast. Go to braininspired.co to learn more. The music you hear is a little slow, jazzy blues performed by my friend, Kyle Donovan. Thank you for your support. See you next time.